bacteria is resistant or susceptible when you look at some breakpoint tables. So I'm going to be talking about the importance of antimicrobial susceptibility testing through this lecture. But first we will look also at what are the leading organizations defining whether bacteria is resistant or susceptible. And we will look at some of the basic of more important in vitro procedures to determine whether bacteria is resistant or susceptible. And we will look also as well when there is some discrepancies when there are susceptible or resistance. Okay, so we do antimicrobial susceptibility testing because we want to be successful when we are treating humans or a human being or an animal against a bacterial infection. So what we do with antimicrobial susceptibility testing is determine whether certain bacteria is resistant or susceptible to the treatment we are going to use to treat that human being or that animal. So when we talk about bacteria resistant or susceptible, there are two main organizations which determine whether bacteria is resistant or susceptible. And the first one is the European Committee on Antimicrobial Susceptibility Testing, known as EUCAST. And the second one is the Clinical Laboratory Standard Institute based in the US. So there are some differences between the EUCAST and CLSI, which I think are worth to mention. The first one is that EUCAST is free. All the documentation is freely available. CLSI, you have to be a member to have access to all the documentation and to the criteria to determine whether an isolate is resistant or susceptible. Other differences are that, for instance, some procedures are different between the CLSI or EUCAST, and also the breakpoints, which might be not exactly the same as in one to the other. So this is something that you have to keep in mind. And as well, a bit of the categorization of susceptible resistance, which we will go through this categorization right now. So, for instance, EUCAST has 3 different categories, whereas CLSI have 5 different categories for an isolates. And so this might be a disadvantage because we don't have a unified categorization at global scale. So from now on, I will focus now in the EUCAST where I have some access to the documentation of the categorizations of isolates. Just let me mention that there is some categories that are, somehow similar, like susceptible is the same as in EUCAST and CLSI. Susceptible increased exposure is basically susceptible dose dependent here, and the resistant, which is also in both organizations. So let's see what is a susceptible isolate or a microbe. So according to EUCAST, when we have a susceptible isolate or bacteria of microorganism, is the one that when we have a high success of therapeutic success with a certain antibiotic. So here is the definition: a likelihood of high success. So what is a resistant isolate? Well, in this case, the success is very low, or there is any little chance of having success using antimicrobial. So this is bacteria you don't want to have. The first category by EUCAST is susceptible increased exposure. So this is also a susceptible isolate where to have success you need to increase the dose or the dosing regime. So we can say that it's a kind of intermediate isolate. So how CLSI and EUCAST determine whether isolates are resistant or susceptible? So everything starts with an isolate. So we need an isolate which will be used to test against antimicrobial. And so there are 2 main in vitro techniques to determine susceptibility, and these are the distribution and the minimum inhibitory concentration, which I will explain very briefly in the next slide. So an in vitro, this diffusion of a susceptible isolate looks more or less like this, where we have an amount of bacteria here. But what you can see is that not all the bacteria can grow. And this is because we have an antibiotic here, a paper impregnated with a certain antibiotic, which is prevented that the bacteria will grow. So we can say that this is a susceptible bacteria because it's not growing around this disc. So the opposite will be when the bacteria grows around the disc. So the antimicrobial is not working or is not killing the bacteria. So we have here a resistant bacteria. And a susceptible increased exposure bacteria using this diffusion will look more or less like this when there is some inhibition zone, not as greater than when there was a susceptible, but there is some inhibition. The second in vitro technique is called the minimum inhibitory concentration. And the definition is written here is the lowest concentration of antibiotic required to inhibit the growth of an organism. And this is a plate that is very often used to determine the minimum inhibitory concentration of an isolate. Where you have here are different antibiotics with different concentrations. And so what you have is when you have some growth of the bacteria, you will see some dots, and what you also see here. So you are testing different concentrations of antibiotics when you put here the isolate, and you see whether it grows or not. There is a video to see. Let's have a look at this. So what we see here is this machine is providing all the isolate in each of the wells automatically, which is just fantastic. So what we have here is a breakpoint table where it's giving us the susceptibility or resistance of antimicrobials of an isolate against some antimicrobials. In this case, cephalosporins monobactams. So in this case, it's telling us, for instance, when we have an isolate that has the value of 1, we can say that this is a susceptible. When we have an isolate that the MIC value is greater than 4, we can say that this is a resistant isolate. And the same is for some diameter in the disc diffusion. So in this diffusion, we are looking for greater values when we are looking for the susceptible isolates. So and the resistance is when the inhibition zone is less than 24 millimeters. So, which is quite the opposite. Here we want lower values in MIC when we want to have a susceptibles, and when in the disc diffusion we are looking for more greater inhibition zones. This table is provided by UCAST, these breakpoint tables. It's worth mentioning that these breakpoints tables are not only determined by minimum inhibitory concentration and the disc diffusion. There are other criteria such as the clinical experience using the antimicrobials, clinical in vivo trials, and as well as the pharmacodynamics and of the antimicrobial, how it's eliminated or distributed within the bodies. And here we have a graph of these breakpoints that I just been mentioning. On the green, we have what is called the susceptible, referring to the minimum inhibitory concentration. In red, we have the resistance. And this is the inhibition zone in the x-axis, referring to disc diffusion. So the greater the disc diffusion is more susceptible, we will find the susceptible isolates. When there is no or minimum inhibition in the disc diffusion, then we will have the corresponding resistant isolates. And in between, we will have what is called the susceptible increased exposure. So when we have a number of minimum inhibitory concentration values, we can make a distribution like this, and where we have here in the x-axis the micrograms per milliliter of a certain antimicrobial, and we have here on the y-axis the number of isolates. So what we see is that when going to the right, so more amount of antimicrobials there, the less likelihood that we will have a susceptible isolate. And so the larger the mixed value, the lower the susceptibility of the organism. The lower here is that we will have a susceptible organism of isolate. These distributions are quite important. So they are important, these distributions, because in some situations there is not sufficient clinical evidence of success using a certain antimicrobial, or there are not enough clinical trials, or we don't know exactly how is pharmacodynamic of a certain antimicrobial. So what is often used is what is called epidemiologic cutoff values. These are abbreviated by ECO-OFF by UCAST, or ACVs by CLSI. The point is that when we can't plot our isolates, and we can determine an epi cutoff, and this will help us to determine whether we are having what is called a wild type organism, or whether it's a non-wild type organism. When we are talking about a non-wild type organism, we are talking about that these organisms have already developed some resistance. So it is important to mention this, because when you have this wild type, you might have a success treating a human being or an animal. And this is because there are not breakpoints, breakpoints for every organism by UCAST or by CLSI. So there are sometimes when this is important and it has to be done, the epidemiological cutoff. It's also important to see that some breakpoints considerations, because the breakpoints will tell you whether you have a susceptible or resistant isolate. However, the success in the real life depends very much on whether the antimicrobial can reach the zone or the organ which is affected, or the tissue. So some responsibility is now on the clinicians. Or other situations about the patients. Some patients where there are might have in a critical situation that cannot absorb correctly the antimicrobial where in the place where it's needed. There is also a situation where we have what is called the area of technical uncertainty. So this is a table of area of technical uncertainty. Well, it's a breakpoint table, but it's showing us here what is called the area of technical uncertainty, and it's just buffer zones. Here is also for this inhibitory concentration, where between 22 to 24 is area of technical uncertainty. What is this? Well, let's see a graph to explain me this more correctly. So the area of technical uncertainty can be seen here when we have some overlapping. In this graph, we have here the inhibition zone and the diffusion, and the colors on green are the susceptible, and the red ones are the resistant. So we have here some overlapping between this, the area of technical uncertainty between 22 to 23. So this is a situation where we cannot conclude that, for instance, that isolate is completely susceptible. So that the recommended situation here is that we have to perhaps to downgrade it, our result from, for instance, if we from susceptible intermediate, we probably have to say that is resistant, or we might just have to report that to the clinician, or maybe another techniques like PCR, or to report this to the technician, or even repeat the technique if we are suspecting that something went wrong in the analysis. So if you want to learn more about this, please go to this YouTube video where you will learn more about this categorization explained by the UCAST, one of the executives. And this area of uncertainty is also explained with more detail. And I will encourage you to visit this video and learn more about this categorization. It's also important to remember that these global antimicrobial resistant surveillance systems, we need to contribute all to this. And UCAS, for instance, is encouraging that we submit meat distributions so we have more information and so we can make better or more accurate what is called breakpoint tables, or we can detect whether there is an emergence resistance. So it's a collaboration effort from everybody. And so to download these files, so these templates can be accessed here also in UCAS, where you can download these forms to contribute to this global effort of antimicrobial susceptibility. So it's time for a quiz, a short quiz. I have here what is called a breakpoint table of E. coli, of amikacin, where we have susceptibles when there is equal or less than 8, or resistant when it is greater than 16. So I have here the isolates, 8, 4, 8, 16, and 64. Can you help me to determine which ones are susceptible into increased exposure or resistant? Pause your video and let me know which ones are susceptible or resistant, please. Yes, you are correct. The 4 is susceptible. The 8 is also susceptible. 16 is susceptible increased exposure because it's between these two. And 64 is a resistant isolate. So we have prepared more quizzes and exercises for you to, consolidate what we have seen in this video. Please have a look at them. We learned today about the importance of antimicrobial susceptibility testing. We look at these categorizations of susceptible, resistant isolates, and we saw why CLSI and UCAST are determining this categorization, how they do it, and we learn about these breakpoints given by the minimum inhibitory concentration and distribution. And when sometimes we need to use the epidemiological cutoff values when there is not breakpoint tables. That's it.